Hello everyone, welcome back to lesson number 28 where we're going to do two more Euler's method problems. In this video I do not have the charts because it's pretty easy to do. So let's go ahead and do these two examples. So example number 4 says if dy dx equals xy squared and y equals -1 when x equals 2, again that's our initial condition, what's the approximate value of y when x equals 2.4? Let's use Euler's method when delta x equals 0.2. So first thing I do is I do x, do y, dx, dy, dx, and dy. And this is dx. I mean, it really doesn't matter if it's delta or x. So here we go. And I go ahead and start with my first column. X is equal to 2 when y is equal to -1. Delta x is 0.2. And I want to get to 2.4. And so I'll go ahead and just go 2 plus 0.2 is 2.2, 2.4. And so I put a box here because this is the answer I want. And I go ahead and do 0.2 here. And I just got to fill in the rest. So dy dx is going to be x, which is 2. Let's change colors here so we can do a little bit here. So dy dx is going to be 2 times -1 squared. So that's going to end up being 2. And then dy is going to be the product of these two numbers. So it's going to be 2 times 0.2. And you guys don't have to write out these numbers right here. We're just looking for the actual answers. So you guys can just write 2 in this box, and you can write 0.4 here. And I'm not wasting time and drawing lines everywhere. I'm just kind of going ahead and doing the answer the way I normally do it. And then remember that this answer, and again I'll change colors, so this answer right here is going to be -1 plus 0.4. So we're going to get -0.6. All right, so that's our new y. So remember, we have to, do not think that the answer that you see here is what goes there. Remember, you have to take this change in y and then add it to the -1, right, which is -0.6. And now we're going to continue on. We're going to have x, well, our x now is going to be 2.2. Our y is going to be -0.6 quantity squared. And we're going to get that this answer is 0.792. And we're going to take that number and we're going to multiply it. So 0.792, we're going to multiply it by 0.2. And we're going to get that answer as 0.1584. All right. And then we're going to finish this question up by taking this number here, and we're going to add our now change in y, and our final answer is going to be -0.4416. So f of 2.4 is approximately -0.4416. And you could absolutely solve this differential equation if you wanted to, and then plug in 2.4 for x to see what your y value would be. So again, this video is just on Euler's method. So let's look at one more example for Euler's method, and it's example number 5 right here. And just like before, ladies and gentlemen, we're going to do x, we'll do y, let's do delta x, let's just do delta y over delta x, just keep it constant. Again, it doesn't really matter, and then delta y. And I go ahead and I draw myself a little line here. And let's go ahead and just do our little boxes, little lines right here. X is -3 when y is 4. Delta x is -0.2. And I'm going to try to get to -3.6. So I'm going to go ahead and add, well, really subtract 0.2 from -3. I get -3.2 and 3.4. And this is the answer that I want. And you guys can see that as we go through these problems, again, it's just the same old thing that we do with everything. So let's go ahead and start plugging in our values. So for our dy, we have a negative. Our x is going to be -3 over our y, which is going to be 4. That's going to give us 0.75, which is pretty obvious. And then we're going to take 0.75, and we're going to multiply that by our delta x. And we're going to get -0.15. And we're going to take 4, and we're going to subtract 0.15 from 4, and we're going to get 3.85. And like I said, guys, as we move throughout the rest of this, it's pretty straightforward. You know, we just have to remember that we're doing a now new x, so it's going to be negative, and it's going to be a negative 3.2 all over our new y, and that's going to give us a decimal answer of 0.8311. We're going to multiply that number by negative 0.2, so negative 0.2, and we're going to get negative 0.166. Let's do 23. Go ahead and just go a couple decimal places, but 0.166 is totally fine with what's going on. We're going to take this number and we're going to add this to it, and we're going to get, this is 3.86837. And to kind of summarize the rest of this, we then use our negative 3.4 all over our new y value, which again is 3.6837. We evaluate this using our good old calculator, and I'm going to get 0.92297. We're going to multiply this by negative 0.2, and we're going to get a decimal answer of negative 0.185, and then we're going to take this value right here. We're going to subtract that value from it, and we're going to get an answer of 3.494. And that is our final answer for this. So f of negative 3.6 is approximately equal to 3.494. So this is the value of our differential equation at negative 3.6, given this initial condition. And that's it. Pretty straightforward. That's Euler's method, ladies and gentlemen. That's all you do. You know, there's different teachers that explain it different ways. I think this really simplistic chart is a really good way of just showing you guys what to do. And, you know, the third column is always the green constant. So it's pretty awesome. And you're going to, again, always be given the differential equation. You're always going to be given your initial value. You're going to tell you what your delta x is going to be. And then you're going to ask, okay, what are we trying to evaluate? So that's it. I will see you guys in our next video. Take care.